Hello, my name is Fatih Furkan Erkeç, and I'm going to do lab 3.4. In this lab, we will continue exploring the biomechanical vertebral column dataset. We will first split the dataset into three separate datasets for training, validation, and testing, and then we will use the data to train a machine learning model by using XGBoost algorithm. So let's go to AWS. Okay, now let's go to SageMaker and open my notebook. Okay, uh, introduction to business scenario. We work for a healthcare provider and want to improve detection of abnormalities in orthopedic patients. And we were asked with solving this problem by using ML. We have access to dataset that contains 6 biomedical features and target of normal or abnormal, and we will use this dataset to train an ML. About this dataset, we have 100 normal patient, 60 disc hernia patient, and 150 uh, spondylolite uh, patients. I can't read it correctly, I think. And each patient represented in dataset by 6 biomechanical attributes, as we can see here. And following convention is used to class labels DH, SL, NO, and AD. So let's set up this lab by running it. We start by downloading the dataset and load the data and uh, define a class mapper, abnormal and normal, and let's run it too. So let's explore the data. We use shape to examine the number of rows and columns, and next we get a list of the columns. Here we can see the column names, and let's propagate the data. We must split data into 3 datasets. An internet search will show many different ways to split datasets. Many code samples that we might find will split the dataset into target and features. Then they will split each of those two datasets into 3 subsets, which results in a total 6 datasets to track. Moving the target column position, XGBoost requires the training data to be in a single file. The file must have the target value be the first column. Get the target column and move it to the first position. Now we should see that the class is now the first column. As we can see, it was public instance, but now it become class. Now splitting the data, we will start by splitting the dataset into two datasets. We will use one dataset for training and split the other dataset again for use with validation and testing. We will use training test split function from scikit-learn library, which is a free machine learning library for Python. It has many algorithms and useful functions, such as one we will use now. And because we don't have a lot of data, we want to make sure that the split datasets contain a representative amount of each class. Thus, we will use the stratify switch. Finally, we will use random numbers so that we can repeat the splits. So we use train test splits to our dataset. Next, split the test and validate datasets into two equal parts and examine the three datasets, as we can see. Now check the distribution of the classes. Okay, we have in train sets 168 by 80, and these are normal and abnormal, 21 and 10 in test set and 21 and 10 in validate set. Uploading the data to Amazon S3, XGBoost will load the data training from Amazon Simple Storage Service. Thus, we must write the data to a comma separated values CSV file and upload file to Amazon S3, starting by setting up some variables to the S3 bucket, then create a function to upload CSV file to Amazon S3. We can reuse this function. First, explore the function, not following line. This line. This line writes the pandas data frame which was passed into the function into the IO buffer that's named CSV underscore buffer. We use a buffer because we don't need to write the file locally. To stop the column headers from being written out, use header equal false to stop the pandas index from being output. Use index false to write the CSV buffer to Amazon S3 as an object. Use the put operation on the object, which is a property of the bucket. So let's run this. Use the function that you created to upload the three datasets. We upload train test and validate sets to S3, Amazon S3 service. Now we can train a model. First step is to get XGBoost container URI. We import Boto3 from SageMaker and retrieve Boto3 session. So next we must set some hyperparameters for the model, because this is the first time we are training model. We can use some values to get started. We use the estimator function to set up the model. Here are a few parameters of interest. Instance count, this defines how many instances we will use for training. we will use one instance and instance type. This defines the instance type for training. In this case, it's MLM for X large. Import SageMaker. Let's run it. The estimator needs channels to feed data into the model. For training, the train channel and validate channel will be used. So we run train channel and validate channel codes in here. Running fit will train the model. It could take up to 5 minutes, and we'll wait for it. So let me pause the video in here and I will continue. Now the training is complete, but we won't use it now. We are ready to evaluate and test the model, but we will do testing and validation in later labs. So thank you for watching. Have a nice day. See you later.